In this next lecture, next session, we are going to consider example on the touching spheres. So first of all, let us see what is the touching sphere. So there are two things for touching spheres. One is external touching. Suppose I have the sphere S1 whose radius is R1 and another sphere S2 whose radius is R2. So that meaning of touching is what? That two spheres does not intersect. There is only one point common between that two spheres, so that S1 and S2, these two spheres are said to be touching externally if distance between their centers is equal to radius sum. That is, suppose that C1 is center of first sphere S1 and C2 is center of second sphere S2, and if distance C1 C2, length C1 C2 is equal to R1 plus R2, so that R1 is the radius of first sphere and R2 is the radius of second sphere. If this is the situation, then we can conclude that these two spheres S1 and S2 are touching externally. Now next term we have internal touching. Or spheres touching internally. For this, let us consider this diagram. Suppose we have the sphere called as S1 and its center is at point C1. And one more sphere we have. Suppose that sphere is this, and the center of this sphere is C2. If radius of this second sphere is R2 and radius of the first sphere is R1. You can see that diagrammatically sphere S1 and S2 are touching internally, means that S2 is in the sphere S1 and it is touching here at point P. Now geometrically, these two spheres S1 and S2 are said to touch internally if distance between their centers is equal to difference of radius. That is, we can say that the length C1 C2, distance between the center C1 C2, is equal to difference between the radius. So larger radius is R1 minus small radius R2. If the radius difference is equal to distance between the centers, then obviously you can conclude that the two spheres are touching internally. This is how you can see that. So this length between C1 and C2, if this length is equal to difference between the radius, then that spheres are said to be touching internally. This is about the internal and external touching of the spheres. Now we'll solve the example on this. In that we have to prove that the spheres are touching externally. So let us consider the example. Write down example. Show that the sphere x square plus y square plus z square equal to 25, and x square plus y square plus z square minus 18x minus 24y minus 40z plus 225 minus 40z plus 225 equal to 0. Touch externally. And also find point of contact. To visualize, let us draw the diagram first of all. Suppose this is the first sphere. S1 whose equation is x square plus y square plus z square is equal to 25. This is the second sphere whose equation is x square plus y square plus z square minus 18x minus 24y minus 40z plus 225 equal to 0. Now we want to show that these two spheres are touching externally, means there is only one point of contact, there is only one point common between these. So diagrammatically call this thing as a P. At the center of first sphere is C1, center of second sphere is C2. This will be the radius of first sphere R1. This will be the radius of second sphere R2. Now to show that these two spheres touch externally, we have to show that distance between the centers of these two spheres is equal to sum of their radius. So for that we have to find the center and radius of both the spheres. So let us consider first sphere S1 whose equation is x square plus y square plus z square is equal to 25. Now you can see that this is in standard form. This equation is in standard form, or it is a standard sphere with center at origin and radius 5 square, that is 25. It is a standard form, in standard form with center, we are calling it as a C1, center C1 as origin, and radius R1 as 5. So what is the standard form? Standard form is this thing: x square plus y square plus z square is equal to r square. Equation of sphere with center at origin and ds r. This is about the first. So put it in the diagram. R1 is 5 and center C1 is 0, 0, 0. Now consider second sphere. What is second sphere? It is S2 second sphere. It is x square plus y square plus z square minus 18x minus 24y minus 40z plus 225 equal to 0. Now you can see that this equation is given in general form. Compare this with the general form to get the values of u, v, w and d, and from that you will get the center and radius of second sphere. So comparing this with the equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0, we have 2u is equal to minus 24, 2v is equal to 2u, here it is, 2u is minus 18, 2v is minus 24, 2w is minus 40 and d is 225. So that will be the values of u, v and w. U is minus 9, v is minus 12, w is minus 20 and d is as it is 225. So once you get the values of u, v, w and d, you can write down the center and radius for that second sphere. So center C2 of second sphere, which is minus u minus v minus w, that is what? Minus u, that is 9, minus v, that is 12, and minus w, that is 20. 9, 12 and 20. So put here center for second sphere 9, 12 and 20, and radius is equal to under root u square plus v square plus w square minus d, that is under root u square, that is 9 square minus 9 square, that is plus 81, v square, that is minus 12 square, that is 144, then w square, that is 20 square, that is 400, minus d, that is minus 225, that is equal to, now what it is, 81 plus 144 plus 400, so what it is, 5, 12 and 6, 625 minus 225, that is 400, so it is under root 400, so that is root 400 means 20, so this radius comes out to be 20, radius R2. Now next find out by distance formula, find out the distance between two centers C1 and C2. So it is C1 C2 square is equal to, as we are considering square, it means no need to consider root in the distance formula. It is 9 minus 0 bracket square plus 12 minus 0 bracket square plus 20 minus 0 bracket square, that is C1 C2 square is equal to 9 square is 81 plus 12 square 144 plus 20 square is 400. So that implies C1 C2 square is equal to 625. So C1 C2 by taking root of 625 is 25. Therefore, the distance between the two centers is 25. And what is R1 plus R2? Addition of two radius. R1 is 5 and R2 is 20. It is 25. So you can see that distance between centers of spheres, that is C1 C2, is equal to addition of sum of radius is equal to sum of radius. It implies that spheres S1 and S2 are touching externally. So this completes the first part to prove that two spheres are touching externally. Now to find out second part, that is to find out the point of contact. And here suppose that the point of contact is P. And to find this point of contact, you have to use the section formula, because you can see that the point P is dividing the line segment C1 C2 internally in the ratio 5:20, that is 1:4. So to find out this point of contact, let us draw one more diagram, and you must know the section formula for this. So this is the point of contact. This is, here it is a center C1 whose coordinates are 0 0 0, and this is the center C2 whose coordinates are 9 12 and 20. This length, it is 5. This length is 5, and this length, it is 20. So we can see that point P, whose coordinates suppose are x, y, z, is dividing segment C1 C2 internally in the ratio 5:20. That is 5:20 means what? 1:4. So this 5, you can say it is 1:4. So to find out that point coordinates x, y, z, we have the section formula. What is that section formula? If point P x, y, z divides segment joining x1, y1, z1 and x2, y2, z2 internally in the ratio m:n, then x coordinate of the point P is given by formula is mx2 plus nx1 divided by m plus n. Y coordinate is my2 plus ny1 divided by m plus n. and z coordinate is mz2 plus nz1 divided by m plus n. So here in the example, this point 0 0 we are treating as x1 y1 z1. Point P is xyz, and the point 9 12 20 we are treating as x2 y2 z2, and m is 1, n is 4. So using that, we have x coordinate as mx2, that is 1 into 9, plus n x1, that is 4 into 0, divided by m plus n, that is 1 plus 4. Y coordinate is m into y2, that is 12, plus n into y1, that is 0, divided by m plus n, that is 1 plus 4. And z is equal to m into z2, that is 1 into 20, plus 4 into 0, divided by m plus n, that is 1 plus 4. That gives you x is equal to, this will be 9 upon 5, y will be equal to 12 upon 5, and z will be equal to 20 upon 5, that is 4. Therefore, the point of contact P is 9 by 5, 12 by 5, and 4. This is the second part, point of contact between the two spheres.